Hey, welcome back. So we've been drawing a lot of boxes, and now we're moving on to cylinders, which, funny enough, also involves boxes. Cylinders are really important to learn because a lot of things are cylindrical. Arms, legs, car tires, whoopee cushions, kind of. When it's flattened, it's basically an oval. Or is it an ellipse? Ovals versus ellipses. A lot of people seem to be confused about the difference between the two, so let's get that out of the way. All ellipses are ovals, but not all ovals are ellipses. This oval is also an ellipse, but this egg-like oval is not an ellipse. Ellipses must have 4 equal quadrants. Ellipses have a mathematical definition, blah, blah, blah. Let's learn about ellipses. If you can't remember, you could just say oval, and you'll be right. If you want to be specific, you can call it an ellipse if it passes the fold test. If you fold the ellipse along the longest part, and then again perpendicular to it, you can see that the 4 quadrants align perfectly. And by the way, the longest line is called the major axis, and the short line, perpendicular to it, is the minor axis. You'll probably hear me also using the terms long and short axis. Same thing. When we're talking about ellipses in the context of perspective drawing, we're referring to circles tilted in 3D space. They're foreshortened circles. As I tilt it more and more, it gets foreshortened until it becomes a line, just like a plane of a box would. When I look at this record from straight on, we see a perfect circle and the axes cross right in the middle. When I tilt the record, the circle becomes an ellipse. But watch what happens to the long axis. It doesn't cross the center of the record? Well, this makes sense because the closer half appears bigger than the farther half. But the unintuitive part of this is that the ellipse stays symmetrical 2-dimensionally. So don't try to draw one of these weirdo trapezoid ovals with the long axis crossing the center. Because that oval, that's not an ellipse. Let's go back for a second. What about the minor axis? The minor axis is much more helpful in constructing ellipses and cylinders. It always crosses the center point, and it aims directly at the perpendicular vanishing point. I'll show you what that means in a minute. But right now, I gotta tell you about the Drawing Basics course. This lesson you're watching is a free version of a lesson from that course, but the full premium course has way more stuff. There's 95 lessons and 43 hours of videos so far, and we're only about halfway through the course. If you're ready to jump in, it's at proko.com/drawing. We've already learned how to control line weight with 3 different methods, how to develop confident line quality habits. We've covered shape, including accurate proportions, dynamic and interesting shapes, and how rhythms can help you draw better poses. We're gonna learn all about perspective, and then we're jumping into shading. Again, that's at proko.com/drawing. Stacking ellipses. So an ellipse is flat, but a cylinder is not. A cylinder is basically a stack of ellipses. You'll sometimes see artists drawing these cross-contour curves around a cylindrical form, like an arm or a leg. We're thinking about what the ellipse looks like at that cross-section of the cylinder. When we're drawing a cylinder, we don't need to think of the ellipse at every cross-section, but we at least need the 2 ends. The angle of the minor axis tells us where the stacking ellipses should go. Let's head over to the gym for a second.
Hey, no recording, sir. No recording. Step out, step out.
Let's look at this photo of a barbell. Notice how the ellipse of the plate isn't vertical. It's angled slightly this way, so that the minor axis is perfectly aligned with the bar. So the minor axis also happens to be the z-axis leading to the vanishing point. The same goes for wheels on a car. Unless the wheels are turning, then not. On the other end of the barbell, the minor and major axes will be the same. Then we just grab the ellipse from this side, move it over here, and wait, what? Looks like the ellipse gets wider as it moves away from us because we're seeing that circle plane more straight on. To figure out exactly how much wider, we're gonna need a box. Drawing a cylinder in a box. It might be easier to draw a box in perspective and then fit a cylinder in it. Or not. They're both hard. But it's at least gonna help us understand what's going on. And with practice, it'll become more intuitive. Remember, this course isn't about making it perfectly accurate. In Marshall Vandruff's upcoming perspective course, he'll get more precise. Let's start this by drawing a circle inside of a square. Now, when I tilt this in any direction, the square foreshortens and the edges converge, all that fun stuff. The circle stays tightly inside of the square. It's not going anywhere. And in order to stay tightly inside of that square, it needs to get wider and narrower and tilt in certain angles. Let me show you. So I'm gonna start with a box, and I'll start with one plane. And now I'm trying to make sure I keep this box as much of a square plane as I can. So I don't make this too long or too short. I wanna make it just where I think it indicates a perfect square. And I'm just doing this by intuition here. I feel like that feels like a square in perspective to me. And that will extend this way, and I'll worry about the other end later. Right now, let's figure out how to fit an ellipse inside of this plane. Now there's a few clues that I can identify that will tell me some things about this ellipse. So first of all, a circle inside of a square always touches the square right at the middle of every edge, right? So there's these 4 points where the circle and the square touch. How can we find those 4 points on here, right? I'm not gonna just kind of eyeball it. I mean, I absolutely could depending on how quickly I'm trying to draw this. But if I wanted to get it as close as I can, and if there's some extreme foreshortening going on, it's not much in this one, but if there was, I would draw an X, and that tells me the exact midpoint. And now I'll just draw from that both of these axes, and that tells me that the middle is here and here. Same thing this way, here and here. The closer halves are a little bit bigger than the farther ones. So they get smaller and smaller as they go away from us. So now we know 4 points where that ellipse has to touch. We also know that the minor axis of this ellipse has to be at the same line as this, same angle. And I know that it's gonna cross this center point. So from here, it's gonna go out at the same angle as this. So there's the minor axis. And I know that the major axis is gonna be perpendicular to that. Close enough. We'll have to force it in there. So now I know that it has to be the shortest around here and the longest somewhere along here. So now I know kind of roughly about 8 points of where I have to cross. So I'm gonna very lightly kind of sketch in what I think the ellipse will be. There you go. So see how the major axis, or the part where it is longest, is at this angle. The minor axis is perpendicular to it and also happens to point at that vanishing point that these length lines are going to. And we happen to touch right on those 4 points. And you'll find that there is only one ellipse that can satisfy all of that criteria that we just learned about. There it is, that's that one ellipse. If I try to angle it in any other direction, it won't touch these 4 points. It just won't do it. This ellipse also is an ellipse and not an oval. It has 4 equal quadrants, right? It's symmetrical both ways. It doesn't necessarily cross. Actually, that's one thing that I just realized I was trying to force it to do, is I put that long axis right on the middle point. It should be a little bit more this way because the middle point of the square is gonna be farther away from us. And so right here is actually the middle, the long axis, which actually, now that I look at it, that is actually closer to how I drew the ellipse. I was forced to draw it in that correct spot to make it fit, even though I had marked off that long axis. I had no choice, really. If I drew it this way, I would have not drawn an ellipse. I would have drawn an oval. So there's the center point, the very middle of that square, but the long axis does not cross that. So now, in order to find the ellipse on the other end, let's first figure out what the square looks like on the other side. So let's just project these out. I'm gonna project these out pretty far, just so that there's a pretty big distance between these two ellipses, and that will make them look more different. Problem is that it's harder to keep these lines straight the farther I go. There's more room for error. Okay, so now I have to kind of, in perspective, figure out how much convergence there will be in this. I'm just gonna feel it out. I'm gonna ghost in the other edge. Okay, so there's the square on the other side. Notice how this square already pretty obviously more of a square. This one is much more of a squished diamond. But the farther we go back this way, the more we're looking directly at that square. And so it's going to be turning towards us and becoming more of a perfect square. And this just kind of lined up when I just projected everything, converged things, and then boom, that's just how it works. And now I'm just gonna find an ellipse on this square in the same way. This minor axis, if I keep it going, goes right to the middle of this, right? So the two midpoints are at the same angle across from each other as these other ones, right? Because this is pointing at the vanishing point. Find the 4 middle points of the 4 edges. So now I know that the ellipse has to touch here. I know the angle of the minor axis. I know the angle of the major axis, which in this case, that major axis is gonna actually be very close to that middle. Probably like right here, just like super close, because it's becoming a square. The more of a square we draw, the closer that becomes middle, until it's a perfect square and it's right in the middle. Everything lines up. Okay, so now I know everything I need, and I'm gonna sketch in kind of a loose version of this ellipse. And this ellipse is kind of needs to be wide, it looks like, in order to fit. So now notice a few things. One, this ellipse is thicker. It's a little bit wider than this one. And it's also shorter. So overall, it's kind of smaller because it's farther in the distance. It's getting smaller. Those long straight lines are gonna be the death of me. Okay, so there is a cylinder stuffed into a box as perfectly as I can do it. So do we have to draw a box every time we want to draw a cylinder? No, no. But I had to show you that so you understand how it works. And when you're drawing something like the wheels on a car, you know how to construct it. When you're sketching something and you don't have to be perfectly precise, just remember 3 things. The angle of the ellipse is perpendicular to the length of the cylinder. The farther end will have a wider ellipse. Practice and get a feel for how much. And the sides will converge slightly as they move away. Thank you for watching, and remember to check out the basics course. Many of the students have told me that they've never improved as fast as they are in this course. So come on in, join the community, and support the production of more free lessons like this one. See you next time.